All right, day 6 of these 2 sections. We are going to be working on the preview, which is, again, very similar to what your quiz will end up looking like. But you'll notice at the top here, we've got a couple of questions that aren't, just a bunch of numbers, but actually trying to figure out what something means a little bit. So let me move this over. So when referring to rational expression operations, add, subtract, multiply, and divide, when do you need common denominators? Out of those 4 times, when do I have to have a common denominator? When do the bottoms have to be the same or I'm stuck? Okay. Any others? All right. So when I add or subtract, I have to have a common denominator. I don't need one with multiplying or dividing. Those are just the ones where I factor, cancel, simplify, and I'm done. So, just those 2. Then, for our second part of this one up here, when trying to simplify any rational expression that involves quadratic polynomials, which just means there's something squared involved, what should be your first step? Okay? Either way, golden rule, is there anything in common? I don't care which one you write. I probably, to be perfectly honest, just something like anything factorable, anything in common, anything that I can take out. Something that refers that, hey, can I make this a little bit simpler, a little bit easier to get started with. But again, I'll take anything in that area as long as I can follow what you're thinking with that. So, okay. First part up here. What are the least common denominators for the following rational expressions? Notice it didn't say simplify like it does down below. Just find the LCD and you're done. Okay, no fraction building, no nothing like that. So, again, if I'm not sure on something, where do I go? Well, you know where I go. I go to my handy-dandy little checklist here. It is. Because I look around and I'm like, once I get my parentheses in, of course, do I see any coefficients? Do I see any numbers hanging outside the parentheses? No. Do I see any single variable terms hanging out outside the parentheses? No. Do I see sets of parentheses? Oh, yeah. So, as was stated a little while ago, it's just those, and I'm done. Okay, don't add them, don't build fractions, just follow the directions. What about for letter B? 4x, yeah, because I've got a coefficient 4, I've got a single variable term, x, and there are no sets of parentheses in the denominator this time, so that's it. Okay, that one's ready to go. Now the last one, this could get a little more interesting. So for letter C is my LCD, because I don't see any coefficients, I don't see any single variables. Is my LCD just going to be x plus 8, x squared plus 6x minus 16? No, we got to do a diamond. We got to factor that second one, or at least try to. All right, so let's see. Multiplies to a negative, so I know it's one of each. So it's going to be 2 numbers that multiply to 16 and are 6 apart. Eight and 2. Okay. So 8 and 2, and again, I know that 8's the plus because the plus is what I needed to be in the middle, my sum. So let me get rid of that because it's factored. So we got a new identity for that denominator. Ooh, now see, I'm glad you said that. Now the question, if you couldn't hear, was do I cancel the x minus 8? Now, I'm not going to do that because when I am trying to cancel things in a certain problem, side to side is the one direction I can't cancel in. But when I'm looking for my LCD, ooh, another good question into this. Would it be x plus 8 squared? Because you're like, well, I see the x minus 2. But I see 2x plus 8. Does it mean I need 2 of them? And here's my answer to that question. The only time we're going to use squared with a parenthesis is if the same set of parentheses is found in one fraction. If I'd have had 2x plus 8s in this one, where I could rewrite it as x plus 8 squared, I'd put squared. But since it's in a different fraction, I only use it once. Just like I do with if I had single variables. Okay, I just use the one that has the biggest exponent. And in these cases, that'd just be 1. So I'm not going to use squared, I'm just going to use x plus 8. 2 excellent questions there to clean some stuff up. So now we've gotten past the kind of, okay, how do I do this? How do I set it up? Now we actually get to start doing stuff. So down here in the next part it says, if possible, simplify the rational expression, which basically means factor and cancel as much as you can. And just like we have on all of these, and I'm actually going to do it on these first couple before I even start. Once you see pluses or minuses in there, got to put the parentheses so you're not that person on the quiz. Like, what do you mean that person? I mean that person who says, woo, I'm going to cancel these x squareds. Don't you do it. Okay? This is bonded right now. The only way I can cancel this would be if I had the exact same thing. So let's see what we can do with that. Anything in common down here? X. So we'll take the x out. So what's that going to leave me with in the parentheses then? Wow, 3x plus 2. Okay. In the denominator, I couldn't pull an x squared because, yeah, I can only take the one with the smaller exponent. So I get that done, and I notice something. This x that I pulled out now isn't bonded anymore. It's free game to reduce here. So, if I just looked at it like that was my whole problem, 7, 2 minus 1 is 1, and the larger exponent's up in the numerator, so my x would stay up there. And then the 3x plus 2, which doesn't have anything to cancel with, it stays in the denominator. Keep the parentheses, because again, don't be that person. Can't cancel those. Bonded. That's as simple as I'm getting. Okay. So factor, 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 then start looking about, can I cancel this? Can I cancel that? Because otherwise I can get a little shady. Okay. So, number 2, again, we can't cancel anything at the start because I see the parentheses and things there. So, question. I don't see anything in common up top with number 2, but can I do anything with it? Oh, they're perfect squares. So, okay, 2x, okay. What about the 49? 7. And it's always plus minus, right, because that's the difference of squares pattern that we've got. Now when I get to the denominator, I got a little more work to do. Yeah, we're gonna have to do it. We're gonna have to do some slide and divide or some guess and check because, well, a couple things. One, it's not a diamond, so I'm not multiplying to get 7 anyway. Yeah, that 2 is gonna slide down there. So I'm gonna just put this down here, do my side work. So this is what's going on down here. So now, though, once I slide that, I should be able to do a diamond. So let's see. 2 numbers that multiply to get a positive. There you go. Which tells me they're both positive or both negative. In this case, both negative, because my sum is negative. I think I'd heard out there with a 7 and a 2. But remember, yeah, since it's slide and divide, that number that I slid has got to get back in here. It now rolling. So it would be x minus 1, because 2 divided by 2 is 1. And since 2 doesn't evenly go into 7, but that's as simple as this fraction gets, I slide that 2 back to the front. Once I'm completely factored, okay, Now I can go back and look and say, okay, is there anything that's identical that I can cancel? And if there is, those are the things I can blast out of there. And whatever's left is my answer. Again, don't cancel inside the parentheses unless things are identical. So factor, factor, factor. That's just what you just got to keep telling yourself on all of these. And then see what you can get from there. Okay. When we get to a problem like 3, notice there's no binomials. There's no pluses or minuses anywhere this time. So personal preference, but normally at this point, these are the one type of problems that I'll actually multiply across right away. So we are going to get some big old numbers here. But that's okay because we have a calculator to help us out with some stuff. So 192y to the 5th when I multiply across, and 100. What exponent's going to be on my x's? X to the 5th, right. Don't forget there's a 1 on this one. And I'll even put a 1 on my y. Now, if you wanted to work on trying to figure out 192 over 100 on your own, I suppose you could. But if you don't want to, I would probably just type it in and do math enter. No decimals, please, and thank you. So 48 over 25, I got that part. My x to the 5th, there are no other x's to deal with, so that just stays where it's at. And then what about the y's? Y to the 4th and on top because the bigger exponent's there. Nicely done. So we kind of keep playing with that idea, but again, it's going to be the little stuff, and a lot of you talk to me about this when we're doing these. It seems to be the little stuff that tends to nab you. Like for instance, 4. 4 is one of those places where the little stuff could get you. What happens when you divide? Yeah, basically what's going to happen here is that this second fraction is going to flip over and it's going to become a multiplication problem. So once I remind myself of that, I go, okay, so I've got x to the 6th, can't really do much with that. What's my denominator going to look like? There you go. I've got a difference of squares, and again, that's what you've got that little help sheet for. If you kind of start to wonder and you're not sure, go to it, kind of get yourself a little reminder of what's going on. And then over here, so these flipped. So the x plus 6 is on top, and the 4x to the 4th goes to the bottom. But there was nothing to factor as far as that goes. So let's see here. What can we do? All right, x plus 6, see you later. Now at this point, some of you may feel comfortable to keep on canceling. Some of you are like, not too sure. If you're not sure, let's go ahead and rewrite it. And then we can take a look again and say, okay, let's see, do we have anything else we can still play with here? And the answer in this case is yes. Now I can't do anything with that x minus 6 down in the denominator because it's the only set of parentheses I got left, the only quantity, so we're going to leave that alone.
Could you distribute the 4x if you wanted to or not?
Okay, now that's an interesting question. Could I distribute the 4x to the 4th? Now, technically I could, but it's never going to do anything positive for me. Because here, if I was just looking at that, could I reduce it some? Yes. Now, if I distribute, I may not see that. So here, okay, I still got the 4 hanging out. X squared on top, because 6 minus 4 is 2. And the bigger exponent's on top. And again, that's in parentheses, can't do it with the x's. I'm done. So my personal opinion on the initial question there is, once you've factored, I wouldn't redistribute ever. Because, like I said, it's never going to do anything good for you. All right. So now we get the number 3, number 4 combo question. And I'm actually, this time, since everything's small, I'm literally going to switch their places, turn this into times, because again, divide just means we're flipping the second fraction over. And just like I did on number 3, I don't see pluses or minuses. I'm going to multiply across. I'd rather look at this as one fraction. So 7 times 12 would be 84x to the 4th. 8 times 28. Okay, Harty, do you trust yourself in the morning on this one? I do. 224 x to the 5th. And if I'm wrong, everybody will unsubscribe from my YouTube page. Okay. So, let's see here. I'm being told it's 3/8. Now, see, it was funny. I'm willing to do that, but I was unwilling to do the reduction without help. Okay. So 3/8. Should have just trusted my people. There you go. And then with my x's, subtract. 5 minus 4 is 1. Bigger one's at the bottom. Roll it. Again, just take your time. You've got the skill to get this set and get this done. You just got to make sure that you don't do something silly. Whoa. Then number 6. Oh, there's all sorts of stuff going on here. Okay, suggestion. Before you panic or before you skip it. Since I see everything else as fractions, I'm going to make the 2x minus 5 a fraction. We'll put it over 1. I'm also this time going to take the time to rewrite this because I see the division. So let me rewrite everything because I want everything ready to go when I start doing all of my factoring and canceling and stuff. So again, the division just means these guys are flipping. But before I write the denominator, can I factor it? Yeah. Perfect squares. Okay, just the fact that we're looking at these now and saying, ooh, perfect squares means we're making some progress here. So, all right, 2x and 2x, that gets me 4x squared. What about the 25? All right, so plus 5 and minus 5. So we've got it all written in its proper spots now. Everything's factored that can be factored. Now we can go on our canceling spree. So 2x minus 5s, x plus 3s. Whenever we're canceling, it's always 1 for 1. One set for one set. If there had been 2x plus 3s up here, I can't cancel all 3. So let's see what we got left here. We got x. We got 2x plus 5. Can I cancel the x's? No. Thank you for saying that so I don't have to bang my head into the desk. Okay? And I'm done with that. Again, just watching out for some things. I figure on a quiz like this, I'm giving you enough things to think about without having to put a zillion problems to boot. So, let's see. All right. Add or subtract the expressions. Don't forget you need a common denominator. And again, if you don't remember something, go back to the green sheet and kind of work down the steps. So, okay. No coefficients in the denominator. No lonely single variables. Just sets of parentheses, just quantities that we have. Whatever's in the numerator stays there. It doesn't disappear. Don't let it. So then we get to the part that's probably the trickiest of this whole business, which is building my numerators. Now remember, we look at this like a puzzle. Whatever I have in my old denominator compared to what I have in my new one is what I need to place up top. So normally we've just been kind of checking off, ooh, I got that piece already. And if it's not checked off, that's what I'm putting up in my numerator. And I do that for each of my fractions. Oh, not yet. Okay, I'm glad you said that. You guys are saying all the right things. It's like I scripted this for some of you guys to talk to me. Do not cancel at this point. Okay? Right. And we're going to make a little note here. Don't cancel until you're down to one fraction. Because if you canceled right now, you'd be right back at the original problem. You just did all that stuff for nothing. So we need to distribute. We need to simplify. And if you don't want to write so much, if you're like, man, I'm going to run out of room again, do what we did before, which basically is do your distributing and just kind of write it little up above here. And then when you go ahead to do the next part, it'll save you a little bit of space. Okay. Once that denominator is the same, you leave it alone. Don't do anything to it. And now I'm just putting together like terms. 4x and 2x is 6x. Negative 8 and 6 is negative 2. Before you circle. Can I do anything else to the numerator? You could take a 2 out, because they do have a 2 in common. And we've had this discussion before. No, it didn't make something that you could cancel this time. So technically, either of those would be right. But again, about the time you don't do that last step, something's going to cancel, and then you're going to lose points. And you're going to be like, oh, why didn't I just do it? So that kind of needs to be the attitude we take towards that. Okay. So number 8. Number 8, we're going to have to do a little thinking this time. I do have coefficients this time, 5 and 10. So what is my common denominator value that I'm going to use going to be? So remember, when we're looking at these, it's like you're taking the two numbers and you're just going to start counting by those numbers until you see a number come up in common in both lists. In this case, that's going to be 10. We have a single variable term, x, and no quantities, no sets of parentheses this time. So that's my LCD. I'm going to rewrite what's already in the numerator, because it doesn't disappear just because we're rebuilding things. And this time, we're going to have to do a little more thinking. Because it's like there's not like a 5 for me to check off, but let's think about it. 5 times what gets me to 10? 2. And I also need the x, because there wasn't an x in my old denominator. 5 times 2x is 10x. That's the whole idea of how we build. But then we get a nice break. What about the second one? I don't need anything. I mean, if you want to write something, I guess you could write 1. But otherwise, 10x gets to 10x. I got that part already. So now I just look and I go, okay. 3x times 2x is 6x squared plus 4 over 10x. You know what I'm going to ask next. Okay, are we done? Can I do anything up to the numerator? I could take out a 2. And here is our reason why we actually do this. Can I reduce the final fraction this time? Yes. Because the stuff that's not in the parentheses is fair game, and 2 goes into 10. So 2 goes into 10 5 times. Okay, if you wanted to put a 1 out here, you could, because 2 over 10 reduces to 1/5. So that time, if I didn't take out my 2, and I left my answer as this, I'd lose a little bit. Like, let's say that was a 4-point question, you'd lose 1 out of 4. So, I mean, it's not terrible, but we don't want to lose points anywhere. So, it's worth our while to get that done. All right. Number 9. Factorable denominator. They're like probably 7 and 2, okay? What about my signs? Both negative, because negative times negative is positive and adds to a negative. Nice. Okay, so we're going to get rid of those. So x minus 2 and x minus 7 is going to be my common denominator. Like we talked about before, unless I see a squared in one of these, I'm never going to use squared in my denominator. I got a 5x minus 1 and I got a 2. Okay. All right, let's see here. It's always nice to see an easy fraction, and it looks like the first one is. Because I've got the x minus 2 and I've got the x minus 7. I don't need anything in the first one. Thank goodness, we didn't have to box or foil or do anything like that. What about the second one? X minus 7. Which means we've got a little distributing to do. So let's see here. 5x plus 2x is 7x. Negative 1 and negative 14 is negative 15. Can I do anything else with the numerator? No, this time. I actually get to just be done for once. I know. It is about time. Okay, so notice those first three were all addition problems. We went combined like terms, we've canceled out, we went our way. Number 10 and 11 involves something a little bit trickier that we got to think about. Nice thing, we have a common denominator already. Woohoo! We think this is the easiest question on the whole quiz, and it may be if we're careful. 6x minus 36 over x minus 6, because I didn't have to do anything to either fraction. I already had a common denominator. But you know I'm not going to let you off that easy. Okay, we need to take a 6 out up in the numerator. Oh, that's why that was important. Because again, we're to one fraction right now, so there's no reason I see the same thing. I can't cancel. Just get 6. I'm done. So if you're cautious, that'll work out pretty well for you there. And then 11, I'll admit it, I saved the craziest one for last. Denominator on your second fraction, what's that going to factor to? 4 and 3. Get that out of there. And you're like, oh, no single variables, no coefficients. Kind of getting the hang of this. This is starting to get a little easier, if I dare use that word. All right, let's take a look and see what situation we got this time. Again, whatever I have in the old one, we'll check it off in the new one. And if you're not checked off, we include you. And then we're happy on the second one because I notice everything checks, so I don't have to do anything else. So you're like, okay, I thought you said this was the tricky one. This doesn't look tricky. Not yet. There's one. Here comes the tricky. And no, it wasn't the distributing part. The tricky becomes in remembering this is minus. When I'm minusing, it's the entire second quantity that I'm subtracting. In other words, that negative that's here goes to the x squared and the minus 6. That's right, which means my 6 will become positive. And a lot of people forget that part. They'll minus the x squared, but they totally forget about the minus 6. That's why I like keeping parentheses on things. That actually was the tricky part. I don't think the rest of this is going to be bad. So let's see what we got here. I always like to write things in order of degree from greatest to least. So I'm going to write the negative x squared first. And I got a positive 8x. And 32 plus 6 is 38. And you can try till you can try no more. That is not going to factor. So we're done. Sure.
Okay, number 8. How do you get like the 5x? Like,
How did I get here? Okay.
because I know the 2 obviously is 10. I don't understand.
Okay, so we're going to forget, we're rolling back up to 8 here for a second. We're going to forget about the parenthesis part for just a second. So if this were my whole problem, 2 over 10x, and I'm looking to reduce that, let's even forget about the x part for a second. So if I'm looking at that, 2 goes into 10 5 times. So I can sort of look at this like I look at variable terms. 10 divided by 2 is 5. Where's the larger value at in the denominator? So the 5 would be down here with the x. And I'd have to have something in the numerator to be able to hold the place. Well, in this case, since I already had this set of parentheses up there, that's how this can become this, because I just wrote the parenthesis part in there then. Okay? But again, whenever you're doing that, or even if you took the 2 over 10 and put it in the calculator and hit math, enter, just always look to see where's the number at. Oh, the number's at the bottom of the fraction. That's where it's got to end up.
Because it was like 10 and I was like, what?
Yeah, just reducing that fraction down. Okay, good. Okay, any other issues before we flip to the back and freak out? This one? Because that stuff all canceled out and I'd factored a 6 out of both of these back on this step. So that's all I got left.
So what do you do to x minus 6 that's on the bottom?
They canceled. Because I had one on the top and one on the bottom.
On the other side?
This one?
Yeah.
I didn't do anything with it at the start. I just left it alone. Because it was a common denominator already. We're doing good review as we even go through. This is good. You guys are solid on me making these videos. It's like I never have to wait and try it again. Okay. Now comes the application to see if we actually get it. If a rectangle has a length of 12 over 3x minus 6 and an area of 4x plus 40 over x minus 2, find the following. Okay. Notice we're talking about length and area. When we're looking at a rectangle, area is length times width. Okay? So, to find the width, so if I took area and did length times width, and I was trying to solve for width, I was trying to get W alone, what would I have to do? Divide by L. Okay? So my goal here is to do A divided by L. Do I have both of those things? Yes, I do. What a coincidence. So, I'm going to take my area, and I'm going to divide it by the length. Now we're cooking with gas. Okay. Oh dear. Here goes Harty with his old sayings again that nobody understands. Okay. Which means we're going to flip that and it's going to become multiply. Okay. So get this out of the way. Can I factor that first one? Okay. Okay, no. The only time that I'm going to just multiply straight across the beginning is if there's no plus or minus terms. Once I see plus or minus terms, I'm going to try factoring first. Better. 4. So I'm going to take a 4 out.
2.
Well, no, 2 did go in. It's not like you said 3 and it doesn't go into anything. Okay. And then over here, okay, the 12 flipped down to the bottom. I can't do anything with 12. What about the 3x and the 6? 3. And then 3 times 2 is 6. Again, we flip this guy over, which is why this is up top now. Now I can start wiping stuff out. So I'm like, okay, zap those guys. Now let's see where that leaves us here. So 4 times 3, that'd be 12x plus 10 over 12. We can cancel out the 12s. They're not locked in with anything. So x plus 10 would be my width if I was trying to figure this out. But again, I'd have to look at the different pieces to see how this works. So the perimeter then, when you find the perimeter or something, what are you doing to the sides? Okay, you'd add things up. So here's where I got to be careful. Okay, I got a rectangle here.
You got the x plus 10, y plus 10.
You're in the ballpark here. When I'm doing perimeter, I'm going to have two widths here and here. I'm going to have two lengths here and here. So that's what I've got to add up. So I've got 2, here's my width, x plus 10. And then I have 2 lengths, 2, 12 over 3x minus 6. You're like, ooh, I kind of see where this is going, Harty. Ugh. You're like, okay, let's clean a little bit up here. Okay, this 2, I can go ahead, I can distribute that up to the numerator here. So that'd be 24. 3, now before I write this all, is this factorable? Is there something common I could take out? I could take out a 3. So you're like, okay, so now do I get to cancel? Do I get to, no, it's an addition problem. We're gonna have one tiny nasty part here and then we're gonna be good. You're like, what do I need? Oh, I need a common denominator, don't I? Yeah. Okay, nice thing, 1 isn't hard to deal with. That is my common denominator. The 3x minus 2. Now the positive thing about this is my second fraction's easy because it already is 3x minus 2. Check, 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 check. Okay, good. First part, not quite as fun. Because I've got this 2x plus 10, but now what am I having to multiply it by? What do I have to multiply 1 by to get to this? The whole thing? Now you may think that looks like the worst thing ever to multiply out, but it's really not. I know, I got a little crazy on this one. So this room I have back under my little drawing is what I'm going to use. So you're like, okay, so how are you going to do this? I'm going to take the two sets of parentheses and I'm going to multiply them together. So let me get this boxed up and work that out. And once I put together my like terms, once I've simplified it, I've only got one piece left, and this is actually going to be done already. It's kind of surprising that it goes this quick. Because I notice what's the one thing I haven't dealt with yet. I haven't dealt with the 2 and the 3 that are out here. So if I times those together, 2 times 3 is 6. I just got to multiply that through. Yes. 6 from doing 2 times 3 right here. So I look at that and I go, okay, so 6x squared plus 48x minus 120. I'm going to scooch this just a little so we can see that last fraction. And then the only part left is I got to add 24 to it. So I rewrite this. Oh, but we got this. 6x squared plus 48x, negative 120 plus 24 is a negative 96 just looking at one thing for a second, which is why I'm not. No. Okay. I was looking ahead to see if this was going to factor, but lucky for us, it's not going to. I'll put it back in a second.
Okay.
Because I'll tell you, on a problem this large,
How many points is this worth?
YouTube world is going to kill me on this because I'm going to start getting little comments at the bottom of this video that says, you could take a 6 out and then it's going to cancel. And I'm going to go, I know, but my students would kill me and just skip the problem if I kept pressing that hard. But you could actually. You could actually. You could take a 6 out of there and then reduce the 3. But when it's coming to solving something like this, the fact that you nail it on all that other stuff is kind of impressive. So
How many points is it worth?
that particular one with the perimeter, honestly, is probably, let's see, 1 for the LCD, 1 for building, 1 for simplifying, probably 4.
4, that's it.
That's it? It should be like 6 points.
I'll take note of that. Okay, we'll use that for 6. Okay, no, 6 is good. 6, 8. It's on video now.
No, it's not. You never said yes, it'll be worth that much.
Minimum 6. Okay, so
2.
now after the crazy mother load question that now you're all telling me you're going to skip, which that's not a good idea. At least do part of it. I'll ease up. So if Brenda's workday totaled 6x plus 10 over x minus 2 hours, and her breaks added up to 2x minus 5 over x plus 2 hours, write a rational expression, okay? Write an expression. It doesn't say reduce, it doesn't say simplify, it doesn't say find, it just says write an expression that represents the time she's working during a day. Okay, when you take a break, is that adding to your work time or subtracting from the time you're working? Subtracting. So all you're doing, okay? Because let's look at this. Okay? One expression, there's going to be nothing complex to this. Notice, I already have a common denominator. Woo! So all I got to do is distribute the negative through. Don't forget to distribute the negative. Kind of important. 6x minus 2x, 4x. 10 plus 5 is 15. I'm done. Should be like half a point question compared to the last one. It won't be, but. Last thing. Bump this up a little bit. Okay, JoJo simplified the following incorrectly. Identify her mistake and correct it. What I would probably do is I'd probably just start the problem at the beginning and do it myself. So here's what I would do. I'd look and I'd say, okay, what's my LCD going to be? I got an x. I don't have any coefficients, but I got this x plus 2. Okay. And I've already got this stuff. So let's see here. Oh, common denominator of x. Check. I need the x plus 2. Okay. And then my second one, I got everything. Thank goodness, something went easy for once. But Rena just nailed it right on the head. The big thing here again, remember, distribute the negative. So I'm like, okay, so this is 3x plus 6. Here, that negative distributes. So I end up with 3x, and a negative x is 2x. 6 plus 3 is 9. So I'm looking through, and I'm like, okay, I got a different answer than they did. So that's the right answer. Now, what did they mess up on? Oh, yeah. Didn't distribute the negative. Yeah. Okay. Now, to me, as long as you can clean it up and show me what's right, I'm content with that. But that's the actual mistake that happened here. Now again, we did a lot of in-depth explanation on stuff, so when you're doing this on your own, okay, make sure, take your time, but, be steady with what you're doing tomorrow.